Okay, now we're going to take care of the quotient rule for derivatives. So it's similar to the product rule, but remember we're starting off with a function in the numerator and a function in the denominator. And we're going to name the numerator one f of x, the denominator g of x, and here's the rule. You take the g of x, the denominator one, times the derivative of the f. Instead of adding, now you're subtracting the original f times the derivative of g, and all of that is over the g function squared. So if we do this right here, we've named the numerator f, the denominator g. Well, the derivative of a constant is always 0. That's going to be nice. And then the derivative of this function looks like it is 12x cubed. And then we're going to follow the rule. So dy, the derivative is the g function times the derivative of f. That's cool. Those will just cancel. Subtract the f function times the derivative of the g function all over the g function squared. Okay, so it looks like that's negative 60x cubed. Now, some professors are going to want you to expand this. Some are not. So for when you start practicing, just practice a couple where you expand that. So that's going to be, you square the first term. Then it's 2 times the a times the b. So 9x to the fourth times 2 is 18x to the fourth. And then you square the second term right there. And then, do all of those things have in common? Yeah. Let's see. They don't all have a 9 in common, but they all have a 3 in common. And technically, right here, we could factor out a 3 from this, a 3 from that before we expanded. We could have done, no, we couldn't because of the square. Never mind. So we're going to do this. So let's see. We're going to factor out a 3. That gives us negative 20x cubed all over 3x to the 8th plus 6x to the 4th plus 3. Okay. Now we've got two binomials. This is f. This is g. So f prime, interesting. So we have 8x cubed minus 10x. And the derivative of the denominator function would be 4x cubed. All right, and then we plug it into. So now instead of dy, I'm going to put f prime of x is the g function times the derivative of the f function subtract the f function times the derivative of the g function. And all of that is over the g function squared. So let's see what we got. We're going to do the first distributive on those 3 things. So that gives us 8x to the 7th minus 10x to the 5th. And then we're going to do the distributive with negative 3, so negative 24x cubed plus 30x. Now we're subtracting all of this. Ooh, and I want to make sure Oh, that was just one term. This is going to be more than that. All right. Let's see. So that gives us 8x to the 7th minus 20x to the 5th. And then all of that. Now I'm going to expand this. So this is x to the 8th minus 6x to the 4th plus 9. That's just x to the 4th minus 3 times x to the 4th minus 3. That's all I did down there. All right, let's see what we have. We have 8x to the 7th, but we have a subtract 8x to the 7th. And then we have negative 10x to the 5th. Well, subtract a negative is add, so that leaves us with positive 10x to the 5th, because negative 10 plus 20 would be positive 10. And then we've got subtract 24x cubed plus 30x all over x to the 8th minus 6x to the 4th plus 9. Okay, in all 6 terms, they all 6 do not share factors. Or we might see it like this. I've had professors have students leave it like that, because you probably had enough factoring in Algebra 1, 2, and pre-calc or college algebra. So I do want you to keep your factoring skills fresh, though. And this is just a little bit more. I think I'm going to keep the video to those 2, but to get you started, and then the G prime. Then just get it set up. I'm not going to simplify it further, but we'll just get it set up. So it's the G times the derivative of f subtract f times the derivative of g all over g squared. Okay, here's going to be the tricky part. When you simplify this over here, you have to remember you're going to subtract all of the pieces when you simplify. So just be really careful about that step. That's typically where students will make errors. All right, that's it for this one.